the free response for your test tomorrow. So I plotted the height and the velocity that were given to me, and you can tell this is not a straight line. I know it's not x squared because x squared looks like a parabola going up and getting steeper. It's not 1 over x because 1 over x looks like this. So what's left is the square root of x, and we can always check with our numbers. So I looked, so the height is like my x variable and the velocity is like my y variable because it put height on the x-axis, so I can think about that as like x and y, or my independent and dependent variable. So from 1 to 4, this was multiplied by 4, and from 4.3 to 8.9, that was only multiplied by like 2. And then from here to here, that was times 2, and this was only times 1.44. So what's happening is that the velocity is only doing the square root of what the height is doing. So velocity is going to be equal to some number k times the square root of h, because the velocity is the square root of h, which is where the square root of the x value comes from. It's like y equals k square root of x, and then your y variable in this case is velocity and x is the height. Now I want to do something to make this linear, so I always keep the variable on the y-axis the same, so I'm going to keep the velocity the same, and I'm going to square root the height in order to make this a straight line, because what's happening to h in the equation is it's getting square rooted. So now you just go through, and I'm going to keep my velocities the exact same, 4.3, 6.2, 7.6, 8.9, blah, blah, blah. And now my heights, I have to go through and I have to square root them. So square root of 1, 1, square root of 2, 1.41, and then, I'm not going to write them all out. But then you plot your points. I should have done this before. Actually, I'm just going to show you. I'm not going to. So once you have your square root of h and your velocity, now you just need to plot the square root of h on the x-axis and your velocity on the y-axis. And your test for did you pick the right variables to plot is do you get a straight line? So this is what I got when I plotted my points. Now I need to draw my best fit line. So you're going to take a straight edge like a protractor, and you're going to make sure you have some points above the line and some points below. You do not have to have any of the data point, like the actual points, in your line. That's totally fine. As long as you have some above it and some below your line, you're good. You also don't have to force it through the origin. That's fine. Just drawing your best fit, some above, some below. And then we want to find our slope. So you want to find 2 points that are on your line, not any of the data points, but 2 points on the line you drew. And then you're going to find your slope. And slope is just the change of the y variable over the change in the x. So in my case, my points were 0.84 and 2.21, or 10, sorry. Everyone's going to have different points. It just depends on like what your best fit line is. And then your slope would just be 10 minus 4 over 2.2 minus 8. So I get for my slope 4.29. I don't know why I'm asking you here. Okay, this is a video. And then part D is asking you to find the acceleration of gravity in this experiment. So this is where we need to put an equation to what we have, because we just found that velocity is equal to a slope of 4.29, the square root of h, because I said this equals my slope, the x variable. My x variable in this case is just square root of h. So now our next step is to make this related to some equation that has g in it, or acceleration in it. So we are talking about the height and velocity at the end. It says that the objects were dropped, so because they are dropped, that means that the initial velocity is 0. The velocity at the end would just be v, and then the height they're dropped from is your delta y. That distance that they're dropped is delta y. The only equation that relates delta y, v, and v naught is that last equation, v squared equals v naught squared plus 2a delta y in this case, because it's up and down. V squared, that's like what our y variable is. V naught squared is just 0. And then your a, we're going to call that g, acceleration due to gravity. Now our equation over here was v equal, and we can call delta y or h. v equals 4.29 square root of h. So I want to make that look the same as this. So I'm going to square root both sides. So then v is equal to the square root of 2gh. Now I have two equations that look very similar. They're both v equals, and they both have square root of h in them. So now I'm going to set them equal. 4.29 square root of h equals square root of 2gh. And then the square root of h's cancel out. So I have 4.29 equals the square root of 2g. To get rid of the square root, I'm going to square it. I get 18.37 equals 2g, and then you just divide by 2. So I get that my g was 9.18. Now your g should be a little bit different because your slope right here, the 4.29, is a little bit different, but your process should be the same. It's just this number is different, so then your end number is different. So to go through what we did again, we looked at the graph and we said, okay, that's a square root curve, and we double checked it by looking, yeah, the height, the velocity does what the height does, but square rooted. So when the height was times 4, this one was only actually times 2. So v is equal to some constant square root of h, and then I plotted v and square root of h, and I drew my best fit line, and then the slope is my k. So that's where I got the v is 4.29 square root of h. And then I had to pick a physics equation that has v and h in this case was like the delta y. And it also had acceleration g, so that I could then set them equal to each other and solve for the g. Number 2, so a projectile launched with some initial speed of 14 at some angle 40 degrees. So the very first thing I need to do is break this up into x and y. So vx is just v naught cosine of the angle. Vy is v naught sine of the angle. So now make sure your calculator's in your remote. And then that means my x velocity is 10.72 and my y velocity is 9. I also have an acceleration of gravity is negative 9.8. You can put v is 0 in the y direction at the top. That is totally correct. Your y velocity will be 0 at this point. But I'm not asking anything about the maximum height or the time it takes to get to the top. So it's actually irrelevant in this case. And then the only other thing that I was given is this 15. That is a displacement. It's a displacement in the x direction. This is not talking about up and down. It's sideways. So displacement for x was 15. And we are looking for time. So normally we would use the v equals v naught plus at, but I don't know the y velocity because what I'm looking for is the time it takes to hit the wall. My y velocity is not 0 here. It's 0 here, so that I can't use v is 0 at the top. But I do have my x velocity and my delta x, and because x is going at a constant speed, there's no acceleration sideways, I can use my v is delta x over t, plug in the x velocity. Displacement x was 15 over t, and now I just rearrange for time, so I multiply the t up, divide the 10.72 over, and I get that the time it takes to reach the